So now here's a very good question. So the question is, what happens if we want to find the limit as x approaches a of f of g of x? So we want to find this limit of a composite function, but the limit as x approaches a of that inner function does not exist. Or what if the limit does exist and it's equal to b, but the function is not continuous at x equals b? So in other words, going back to that property from our first video, one of those conditions was violated, right? So what happens if that's the case? Well, if that's the case, then we can't say this beautiful string of stuff, in other words, that the limit of the composite function is just equal to the outer function with the limit of the inner function just plugged into it, right? So we can't do what this property is telling us we can do, because one of those conditions would be violated in either of these cases that I'm talking about, right? So what do we do instead? I'm basically just telling you to consider the left and right-handed limits. Okay, so you're going to see in these examples what I'm talking about. Alright, so if we look at this example and I use these graphs of f and g, I want to look at the limit as x approaches -2 of g of f of x. So the first thing I want to check over here, so I want to check the limit as x approaches -2 of my inner function f. I need to make sure that that actually exists. So when I go to the limit as x approaches -2 of f, hopefully you guys see that this limit actually does not exist. And I'm going to say, since the left-hand limit doesn't equal the right-hand limit, right? The limit as x approaches -2 of the function f from the left would be 1, right? And then the limit as x approaches -2 from the right of f of x is equal to 0. Okay, so since the left and right hand limits don't match up, we know the limit doesn't exist. So that means that I can't find the limit of the inner function and just plug it into the outer function to figure out what this limit is. So now what I need to do instead is to consider the limit as x approaches -2 of the left, from the left of g of f of x. And so how I'm going to do that is I'm going to consider the limit as x approaches -2 from the left of the inner function. Okay, so the same idea as I would before, except now I'm considering it from the left. So I'm going to do the limit as x approaches -2 from the left of the inner function, in this case is f. And so we said that this would be 1. Okay. And so what's tricky about this now is when I go to figure out the limit as x approaches some value of g of x, now my outer function, I have to think about, is it just 1, or am I approaching 1 from a certain direction? Okay, because when I give you the limit as x approaches -2 from the left of f equals 1, whenever we give the answer to a limit, we don't think about the direction that it's coming from, right? That doesn't make too much sense to us. But in this case, we have to actually kind of think about what direction we're coming from in terms of looking up and down on the y-axis, okay? So when I'm approaching -2 from the left, let's do these values here. So if I have -2.5, -2.2, -2.1, so as I'm approaching -2 from the left, do you guys see how I'm approaching from above? Well, hopefully you guys are like, yes, I do see how you're approaching that open circle from above. So if you're approaching from above, that means that you're approaching technically from the right. Okay, so I'm going to say that this is coming from the fact that coming from above. Okay. And so when I go to this part where I do the limit as x approaches 1 of the outer function, I don't just put 1, I put 1 from the right. And so now when we look at the limit as x approaches 1 from the right of g, I see that the answer I get is -1. So that means that this composition, the limit as x approaches -2 from the left of g of f of x, is equal to -1. Okay, so we only do this idea where I'm talking about the direction for the y values when I need to consider the limit of a composition of functions in this circumstance. Normally I would love to use the property that we used in the first example, but if that fails and we have to consider left and right-handed limits for composition, then this is the only weird part that we have to do. We have to start with the limit from the left and then look at the limit as x approaches that number from the left of the inner function. Figure out what direction I'm approaching that number from. If it's from above, then I'm going from the right. If it's from below, then I'm going from the left. Okay, and then from there, look at the limit as x approaches whatever that number is of the outer function. That will give you the answer for that side of the limit. Now, to find the final answer, we need to do the same idea now, but for the limit from the right. So let me give some more room here. Sorry about that, guys. Just want to make sure I have enough room here. So I need to do the limit as x approaches -2 from the right of g of f of x. Okay, and so same idea. Now I'm doing the limit as x approaches -2 from the right of the inner function f. And now when I'm approaching -2 from the right, I need to start in between -1 and -2. So plotting these points, I see them getting very, very close to the y value of 0. And hopefully you can see again that I'm coming from above. So I would say that this is 0. And then again, this is going to be, because I'm coming from above, I'm going from the right. So this will be 0 from the right, which means that now when I look at the limit as x approaches 0 from the right of the outer function, this will give me the answer for the limit as x approaches -2 from the right of that composition. So now when I look at the limit as x approaches 0 from the right, I should get that the answer is -2. Right, coming from 0 from the right, this is 1/2, 1/3, I don't know, 1/4, and I'm getting really, really close to that value of -2 there. So, oops, sorry. So that means that this is going to be -2. Now I look at these two answers and I'm like, okay, does the left-hand limit match with the right-hand limit? So in this case it does not. So the answer is that this limit does not exist. Now you might ask yourself, is that always going to be the case? If I have the limit as x approaches some number of a composition and I can't just use that property, does that mean the limit doesn't exist? No, it doesn't. Okay, so you will see some examples where when you do this long process out, you actually will get that the limit exists. So it is really important that we understand how to do this and that we take our time with it and make sure that we know exactly what the answer is.